All right, so today's date is Monday, December 9th, 2019. Today we're doing equivalent forms of exponential expressions. So 12/9, 2019. Okay, so our objective today is to use rules of exponents to find equivalent forms of exponential expressions. Very similar to what we were doing on Friday. I think all of today is purely multiple choice. So just a review of the properties that we've been doing thus far. Anything to the power of 0 is always 1. X to the power of negative n, and you should be pausing the video or at least giving yourself time to think like, what is that? So just like a quick pause, like for 5 seconds, and then reveal the property. So you're pausing, and now you've unpaused after 5 seconds. This is 1 over x to the power of n. And I'm going to be writing notes off here to the right hand side. I think it's kind of helpful. Anything to the power of 0 is equal to 1. And don't forget about this guy's cousin. So this guy's cousin is 1 over x to the negative n is x to the power of positive n. So if I flip between numerator and denominator, it becomes negative. Down here, you're pausing the video, and this is x to the power of n plus m. So multiply, you can say times base, that implies add power. I guess I can be doing that more consistently in a separate color. Alright, what about this next one? Again, pausing the video, and you're unpausing x to the power of n minus m. That means when I divide the base, that implies that I subtract the power. When I have a power to the power, that is x to the power of n times m. So that means if I guess I'm going to go like this. So if I have a power to a power, that implies multiply power. And then both of these are distribution. You should be able to do these x to the power of n times y to the power of n, and this is x to the power of n divided by y to the power of n. So both of these, I would just say, don't forget to distribute. Alright, so that's a good review. Example number 1. We need to figure out if these expressions are or are not equivalent to the power of 3t squared minus 4t. So I'm going to just turn them all into exponential form without any fractions or anything. Notice that you need to have the same base in order to subtract their powers. So let's first get to the same base. And this one, 8 is the same thing as 2 to the power of 3. And that's still to the power of t squared. On the bottom in the denominator, we have 2 to the power of 4. And that's to the power of t. Just changing their base now. Okay, so when I have a power to the power, that means I multiply. So that means this is going to be equal to 2 to the power of 3t squared. On the denominator, we have 2 to the power of 4t. And then whenever we are dividing the bases, that means we are subtracting the powers. So that means that this one is going to be equal to 2 to the power of 3t squared. And then we're going to subtract this other base of 4t. And hey, bada boom, bada bing, we can circle it. I'm going to either circle or cross them out. This one is equivalent. Let's try this next one, b. So I have a power to the power, so this is going to be 2 to the power of 3t squared. The bottom can't really change anything, so 2 to the power of 4, that's a bad 4, 2 to the power of 4t. And then from there I'm going to subtract because I'm dividing the same bases. So this is going to be 2 to the power of 3t squared minus 4t. And hey, it's the same thing that we've been doing. So again, that is another answer. Let's try another one. So again, I need to have the same base in order to multiply. So this is going to be 2 to the power of 3. So this is 2 to the power of 3, and then that's all to the power of this t squared. So t squared. And that's going to be times 16. So 16 is 2 to the power of 4, 2 to the power of 4, and that's all to the power of t. Whenever I have a power to the power, that means I'm multiplying, so this is now going to be I guess I use green to be consistent with my color changes. 2 to the power of 3t squared, and this other one is going to be 2 to the power of 4t. Whenever I multiply bases, that means I'm going to add their exponents, and therefore our answer down here is going to be 2 to the power of 3t squared plus 4t. 4t, and I can have a little curve on that t to make sure it's not a plus. And then you'll notice that that one is not an equivalent form because we have a plus sign and we are looking for a minus sign. So that one I'm going to say no, that is not an equivalent form. Let's try 2 more examples. So example number 2, determine whether these expressions are equivalent to that beast. Okay, so I'm going to, again, try to turn everything into exponential form. Looks like this is B is the most simple form, so I can't really compare B. That means I'm going to have to simplify this one first. So get everything as simple as possible. I'm noticing a lot of 2's that are happening, these are all powers of 2. In fact, 16 is a power of 2. I'm going to try to get everything with a base of 2. I think that's my strategy for this one. So if I do that, this equation, or this expression, 16 is 2 to the power of 4, and that's all still to the power of this 5t plus 0.5t plus 0.25. So this is 0.5t plus 0, or plus 0.25. Okay, so now it's almost as simple as possible, and again, I can go one more step further and say, okay, well, this 4 is going to be multiplied into both of these 2 terms. So 4 times 0.5, or 4 times a half of 4, is 2. So this is going to be 2 to the power of 2t, and then this is going to be a plus sign, and then what's 4 times 0.25, or 4 times a quarter? That's going to be 1. So this simplifies into just 2t, or 2 to the power of 2t plus 1. That's what I'm kind of comparing all of these. Let's do the part A first. So if I do this one, 8 is the same thing as 2 to the power of 3. So this is going to be 2 to the power of 3, and that's all going to be still to the power of 0.5t, all that stuff. So 0.5t, I should curve my t's more, plus 0.25. In the denominator we have, I can actually add these now. So if I have the same base and they're being multiplied, that means I'm going to add these exponents. So this is going to be 2 to the power of t plus 0.5. Alright, continuing on with our simplification, I'm going to distribute this 3 into both of these 2 exponents. So 3 times 0.5 is 1.5, so I have 2 to the power of 1.5 t. And then 3 times 0.25, if I have 3/4, I have 75 cents, so plus 0.75. All right, in the denominator, we have, yeah, I can't change anything. That's still 2 to the power of t plus 0.5. We're really close to simplifying A. Again, now that I'm dividing the same base, I'm really going to be subtracting. So I'm going to subtract t from 1.5t, and I'm going to subtract 0.5 from 0.75. And what do we get here? This is going to be equal to 2 to the power of 1.5 minus t is 0.5t. Oh, it's looking kind of close. And then this is going to be plus 0.75 minus 0.5 is the same thing as 0.25. So plus 0.25. Okay, so that was close. I mean, you can see that is matching up with this one, but unfortunately we needed 2t plus 1, so not quite. We can go ahead and say no, not A. Let's try the next one. 4t times 2. So I can think of this one. 4 is really 2 to the power of 2, so this is 2 to the power of 2, all of this to the power of t, and still times 2. This is technically 2 to the power of 1, right? If I don't have a power on the right hand side, I assume it's 1. Going one more step. If I have a power to the power, that means I'm multiplying, so this is going to be 2 to the power of 2t times 2 to the power of 1. And from here, oh, I have the same base. The same base is being multiplied, which means I'm going to do what operation to the exponents? Sorry, I'm going to add. So it's going to be 2 to the power of, I'm going to add the 2t with the 1. Oh, and hey, that is exactly the same form. So B is an equivalent form. We can circle B. And let's try C. So coming down here, So 32, that's 2 to the power of 5, is that right? So let's think about this. 2, 2, 2, 2, 2, 5 times. 2 times 2 is 4, 2 times 2 is 4, 4 times 4 is 16, and 16 times 2 is 32. Yeah, so this is 2 to the power of 5 here. So I'm going to rewrite this as 2 to the power of 5, and that's still all to the power of 0.25t. And that's going to be times, and then 16 can be written as 2 to the power of 4. 2 to the power of 4. In the denominator, what do we have down here? In the denominator, 8 is really 2 to the power of 3, so this is 2 to the power of 3. Oh, do that a little bit better. 2 to the power of 3, all of this to the power of 0.25t, make that curvy-ish, plus 1. The next step, I can multiply because I have a power to a power. So this is going to be 5 times 0.25. If I have 5 quarters in my pocket, I have $1.25. So this is going to be 1.25. So it's 2 to the power of 1.25. No, go away, cat. I don't want you on my lap. Times 2 to the power of 4 still. In the denominator, again, we can multiply this 3 times both of these terms. So 3 times 0.25 is 0.75, so 2 to the power of 0.75 plus, and then 3 times 1 is just 3. All right, doing good so far. I can rewrite this numerator if I'm multiplying the same base. That really means I'm adding the powers. So, if you caught the mistake, give yourself an extra credit point, but here it is. I was supposed to put a t there. And then from here, I'm going to, as I said, add 2 to the power of 1.25t plus 4. That's all going to be divided by 2 to the power of 0.75. Oh my gosh, there's 2 mistakes there. This is t plus 3. So again, there's 2 chances at getting some extra credit here. There's a t here and then plus 3. So 0.75 t plus 3. And I'm getting low on room here, but now I just need to subtract here. And come down here. If I subtract, because I'm dividing with the same base, right? So I'm subtracting 0.75 from 1.25, so that's going to be 0.5t. So 2 to the power of 0.5t, and 4 minus 3 is 1, so plus 1. Oh darn, that was really, really close. So check it out. So we have simplified as much as we can get. So it was supposed to be 2t and 1. We got the 1, just it was 0.5t, so it was a little bit backwards. So that one is not an equivalent form. All right, so we're almost done. We have our final example, and this one will go a little bit quicker. Determine whether each expression is equivalent to this one, 36 to the power of m over 6. And I noticed that, there's a typo in here. Oh my gosh, so much extra credit. This should be a 6, otherwise that's like purely impossible. Sorry about that. This should be 6 to the power of 2m minus 1. So I can just rewrite this whole thing as 6 to the power of 2m minus 1. All right, so here we go. I'm going to rewrite this one first because I want them all in the same base. So this is going to be 6 squared is the same thing as 36, and that's still to the power of m, all divided by 6. Technically, that's 6 to the power of 1. And from there, I'm going to say that's 6 to the power of 2 times m, so just 2m, all divided by 6 to the power of 1. I guess I should change my color for those, just color coordinate everything. The next step here is I need to subtract since I'm dividing with the same power, so this is going to be 6 to the power of 2m minus 1. And we don't know these two. I mean, this one is clearly correct if I rewrote it correctly. So C is an answer, 6 to the power of 2m minus 1. Let's check why A and B, if they are or are not equivalent forms. So the first step here is saying, okay, this is going to be 6 to the power of 2. That's 36. And then I need to rewrite this power 2m minus 1. 2m minus 1. If I multiply this 2 with this 2m minus 1, let's see what happens. I'm really distributing the 2 into both of these 2 terms. This is now going to be 6 to the power of 4m minus 2, which is not 6 to the power of 2m minus 1. So that's not an equivalent form. Let's try the next one. I'm almost done, but so this is going to be 6 to the power of 2 again, 6 to the power of 2, all of it to the power of m minus 1. Yeah, that's a nice card you've got. And then again, we're going to distribute this 2, and this is going to be 6 to the power of 2m minus 2, which again is not 2m minus 1, so again, that is not an equivalent form. The only answer that you have is C. All right, so that is the final example. Good luck on Khan Academy. Hopefully I will see you guys tomorrow. And I forgot to mention that we have some new news here. That's geometry. Let's go to Algebra 2. There was no warm-up, but there is no test or final quiz on Friday for this unit, just the final. So that means Wednesday is our last day of new material. Our review for the final is going to be Thursday, Friday, the weekend, including Monday as well. So you have 3 days to review for the final. Hopefully that makes some of you happy. And yeah, that's it. I'll see you guys tomorrow.